logarithmic function. So how do we graph logarithmic function? Okay. And how do we determine the domain and range of a logarithmic function? So I'll make it simple for you, same as the exponential function. So we have logarithmic function. Okay. So with a base b, so logarithmic function is the inverse of exponential function. Okay, logarithmic function is the inverse of exponential function. Okay, so it's the inverse of an exponential function. So y is equal to log x with a base b. Okay, so that's the inverse of exponential function, since exponential function is x equals to b raised to y. Okay, so y equals log x with a base b. It came from your exponential function, which is x equals b raised to y. Okay, so b here, you're referring to the base, and then y, you're referring to your function, and then you do have x. Okay, so log function is the inverse of your exponential function. Okay, log function is the inverse of your exponential function. For example, let's say the given is 2/3 equals 9. So how do we write that in logarithm? Okay, how do we write it in logarithmic function? 2/3 equals 9. How do we write that in logarithmic function? So to write it in logarithmic function, it will become what? It will become 3 equals what? How do we write it? 3 is equal to log what? How do we write it in logarithmic function? How do we write it in logarithmic function? It will be 3 equals log what? Log 9 with a base 2. Okay? Log 9 with a base 2. Okay? So 2 here will be your base. Okay? And then 3 here, you're referring to your y. Okay? And then 9 here, you're referring to your x. Okay? So we have log 9 with a base 2 is equal to 3. Okay? So log 9 with a base 2 equals 3. That's how we convert exponential function to logarithmic function. Another example. Let's say the given is 2/3 equals 8. How do we write that? 2/3 equals 8. 2/3 equals 8. What is the logarithmic function? How do we write it in logarithmic function? 2/3 equals 8. Try to take note of this. 2/3 equals 8. How do we write that in logarithmic function? Log.
Then 8 with a base of 2.
Okay. So log 8 with a base 2 equals 3. Okay. Log 8 with a base 2 equals 3. Okay. So that's how we convert exponential function to logarithmic function. Okay. That's how we convert exponential function to logarithmic function. Okay. Now, what about logarithmic function to exponential function? Okay. Let's say the given is log 2 with a base 8 equals 1/3. Log 2 with a base 8 equals 1/3. So how can we convert it to exponential function? Log 2 with a base 8 equals 1/3. So how do we convert that to exponential function? Exponential function. How do we do that? How do we convert? It will become what? It will become what? A raised to 1/3 equals 2. Okay? 8 pertaining to the base, and then 1/3, that will be your y, equals 2. Okay? That's how we convert logarithmic function to exponential function. Another example, let's say we have log 10,000 with a base 10 equals 4. Log 10,000 with a base 10 equals 4. How do we convert that to exponential function? How do we convert it to exponential function? How do we convert it to exponential function? Log 10,000 with a base 10 equals 4. How do we convert that? How do we convert? Log 10,000 with a base 10 equals 4. Anyone? How do we convert? 10,
equals
10,
4.
okay, 10 raised to 4.
X equals to 10,000.
Okay, very good, 10,000. Okay, so 10 raised to 4 equals 10,000. Okay, so that's the concept. How do we convert logarithmic function to exponential function and vice versa? Okay, so take note of this. So logarithmic function is the inverse of exponential function. Okay, this concept came from this. X equals b raised to y. Okay? So that is the relationship of exponential to logarithmic function. Okay, let's proceed now. How do we graph logarithmic function? Okay? And how do we determine the domain of the logarithmic function? Okay. So let's start with the first one. First example: y equals log x with a base 2. Okay. Log x with a base 2. Okay. So how do we do that? First, we need to equate x into 3 numbers. Okay. So we do have 0, 1, and then the third, whatever the given base. Okay. So you need to equate x, okay, to 3 numbers. The first one is 0, the second one is 1, and then the third is whatever the given base is. Okay. So in this particular example, y equals log x with a base 2. How do we graph it? So you need to equate x by 3 things. First, equate it to 0. Second, equate it to 1. And then third, equate it to the given base. In this particular example, what's the base? In this particular example, what's the base? What's the base? Ano yung base? Okay, 2. Okay. Since we're talking about logarithmic function, okay, in logarithmic function, we do have vertical asymptote. Okay? Vertical asymptote. Means, how do we determine the vertical asymptote? Your vertical asymptote is always equated to 0. Okay? Whatever the values of x, when you equate it to 0, that is your vertical asymptote. Okay? Whatever the value of x, when you equate it to 0, that is your vertical asymptote. So in here, your vertical asymptote is 0. Okay? X lang yung given. So more or less, your vertical asymptote is 0. Okay? So we can now plot the vertical asymptote. So x is 0. So the difference between exponential function and logarithmic function, in exponential function, we do have horizontal asymptote. For logarithmic function, we do have vertical asymptote. Okay? Vertical asymptote. Okay, let's proceed now. Okay? So since we already have values of x, we'll be using yung last 2 values of x, which is 1 and 2. Okay? 1 and 2. Okay? So you convert. You substitute. You substitute. If x is 1, okay, what is y? You can use your calculator. If x is 1, what is y? Log 1 with a base 2, what is y? Log 1 with a base 2, what is y? Log 1 with a base 2. Take note of this. Okay? Take note. Log 1 is always 0. Okay? Always 0. And then log, okay, log b with a base b, okay, if they have the same, is always 1. Log b with a base b, if they have the same, yan, same lang, same with the base, okay, your x is the same with the base, that is always 1. So take note of this, okay. Log 1 is always 0. And then log b with a base b, if they are the same value, the answer is always 1. So in here, log 1 with the base 2, regardless the base, if it's log 1, the answer is always 0. Okay? Next, log 2 with the base 2, what have you noticed? Log 2 with the base 2, what have you noticed? They have the same value, right? Log 2 with the base 2, okay? If they are the same, the answer is always 1. Okay? Take note of this concept. Okay? Log 2 with the base 2, they are the same, so the answer is 1. Okay? So you can now plot it. So we have 1, 0. So 1, 0 here. Next, 2, 1. So we have 1, 2, and then here. So how do we graph a logarithmic function? Okay, to graph a logarithmic function, you start with the vertical asymptote. Okay, you start with the vertical asymptote, and then you connect the points. Okay, so here, what will be your domain? Okay? Obviously, your domain will be basically based on your vertical asymptote. Okay? So what will be the minimum value of x based on this graph? What's the minimum value of x? So your domain will be based on the vertical asymptote. So that would be 0 going where? 0 going where? Okay, going to positive infinity. So 0 going to positive infinity. What about the range? What about the range?
Negative infinity.
Okay, negative infinity to positive infinity. So what have you noticed? What have you noticed? Remember that logarithmic function is the inverse of your exponential function. If you have noticed, the domain of your exponential function is the range of your logarithmic function. Kaya siya naging inverse. Okay? So the domain of your exponential function is the range of your logarithmic function. And then the range of your exponential function is the domain of your logarithmic function. That's why logarithmic function is the inverse of a exponential function. Okay, so that's the graph of logarithmic function. Okay, let's proceed now to the second example. So please take note of this one. Okay, next example, let's say the given is y equals log x plus 1 x minus 1 plus 2, okay? Y equals log x minus 1 with a base 3 plus 2, okay? Y equals log x minus 1 with a base 3 plus 2, okay? So y equals log x minus 1 with a base 3 plus 2, okay? First, we need to equate your x by 3 numbers, okay? The first one is x minus 1 equals 0. The second is x minus 1 equals 1. And the third will be x minus 1 equals what? Your base. In this particular example, what's the base? Okay, 3. Okay? So try to follow the 3 things in graphing logarithmic function. So you equate your x value in 3 numbers. First to 0, second 1, and then the third is whatever the base is. Okay, whatever the base is. So in here, the base is 3. So we need to equate it by 3. Okay? Why do we need to equate it by 0? To determine the vertical asymptote. Okay? So we need to equate it to 0 to determine the vertical asymptote. So in here, what is your vertical asymptote? What is your vertical asymptote?
1.
Okay, 1. Okay? So the vertical asymptote is 1. Okay? Next, we need to equate it to 1 and 3. 3 is your base. To determine what value of x we need to use. Okay? To determine what value of x we need to use. Okay? So in here, x will be 2. X will be, okay, 4. So we will be using 2 and 4. Okay? 2 and 4. So 2 and 4. So we have 2 and then 4. Substitute. If x is 2, what will happen? Okay, 0. Why is it? Why is it 0? Is it 0? Is it 0? Is it 0?
Plus 2 pa po pala, miss.
Okay, so it should be what? It should be? Okay, 2. So it should be 2. Okay? Because log of 1 is basically 0 plus 2, so you do have 2. Next, what about 4? If x is 4, what is the value of y? Substitute. If x is 4, take note of this. What is y if x is 4? If x is 4, substitute. So 4 minus 1, that will be 3. Log of 3 with the base 3 is 1. Plus 2, what will be the value of y? Substitute lang. What's the answer? What's the answer? Substitute. The answer is? Okay, 3. Very good. Okay, so 3. Now, after that, we can now plot the given points. Okay, so first, vertical asymptote. So 1. Next, 2, 2. So we have 2, 1, 2. Next, 4, 3. So we have 1, 2, 3, 4. 1, 2, 3. Here. Okay. So to plot it from the vertical asymptote, then you connect the dots that we have. Yan. Okay. So therefore, what is your domain? Based on the graph. What's the domain? Based on the graph. What's the domain? Remember, your domain varies whatever your vertical asymptote is. So in here, what is your domain? Okay, very good. So we have 1 to positive infinity. What about the range? Range. Range is what? As always? Okay, negative infinity to positive infinity. Okay? Negative infinity to positive infinity. Okay? Any more question? Is it clear, people? A natural logarithmic function. So natural logarithmic function. Natural logarithmic function is the inverse of natural exponential function. So basically, okay? Okay, so try to take note of that one. So natural logarithmic function is the inverse of a natural exponential function. So for today, okay, how do we graph a natural logarithmic function? So for example, take note of this, y equals to ln x if and only if x is equal to e raised to mn. Okay? If and only if x equals to e raised to x. So this is the definition of natural logarithmic function. So natural logarithmic function is the inverse of your natural exponential function. Okay, so how do we graph that? So for example, y equals to ln x minus 1 plus 2. Okay? Y equals to ln x minus 1 plus 2. Okay? So how do we graph natural logarithmic function? Okay? So same procedure in graphing a logarithmic function. We need to equate x into 3 numbers. The first one is 0, the second one is 1, and the third is the base. Okay? The third is the base. So we have x minus 1 equals 0, x minus 1 equals 1, and then x minus 1 equals the base of your natural log. So in here, what's the base of your natural log? So the base of your natural log here is e. Okay? Yung base ng ln is e. Okay? As always yun. So the base of ln is e. So we need to equate it by e. Remember, e has a value. Ano yung value ni e? It's constant. So what's the value of e? 2.7. Okay? So the base of ln here, as always, e yun. E. Okay? It's constant. So e is equal to 2.7. Okay? So equated by 0. So we have x minus 1 equals 0. So that will be 1. Okay? So your vertical asymptote is 1. Okay? Next, what about this one? So x minus 1 equals 1. So ano yung value ni x? Okay, 2. Okay? Next, x minus 1 equals e. So that will become x is equal to, what is the value of e? 2.7. Okay? Plus 1. So what is your x? Okay, 3.7. So we can now assign values of y. Okay? So since we already have the values of x, which is 2 and then 3.7, we can now determine the value of y. So we're gonna using 2 and then 3.7. Okay? So you substitute. If x is 2, okay, if x is 2, what will be the value? Okay, 2. Okay, very good. Next, if x is 3.7, what's the value? What's the value?
3 or 2.99.
Okay, 3 or 2.99. Okay, basically it's 3. Okay, so we do have 2 and 2 and then 3.7 and then 3. Okay, so since we already have the values of x and y, you can now sketch the graph. Okay, so we can now sketch the graph. So first we need to plot the vertical asymptote. So we have 1. So 1 pa rin. Next, 2 and 2. So we have 1, 1, 2, 1, 2 here. And then 3.7. So that is between 3 and 4. So the graph from the vertical asymptote going there. So that's the graph of this function. So what will be your domain based on the graph? What's the domain? So the domain is what? What's the domain? Okay, 1 to positive infinity. And then the range is negative infinity to positive infinity. Okay? Negative going to positive infinity. Okay? So that's how we graph a natural logarithmic function. Okay? So any more question in graphing a exponential function, logarithmic function, and then natural logarithmic function? So again, natural logarithmic function is the inverse of a natural exponential function. And then logarithmic function is the inverse of exponential function. Okay?